Hey everybody. Tonight we're going to do a little more work with intercepts, but we're just going to take a look at one example. We're going to work it out, study it, see what we can learn from it. In our example, a submersible designed to explore the ocean floor is at an elevation of negative 10,000 feet. That means 10,000 feet below sea level. The submersible ascends to the surface at a rate of 500 feet per minute. The elevation y in feet is given by the function y equals 500x minus 10,000, where x is the time in minutes since the submersible began to ascend. So we have our equation y equals 500x minus 1,000. So that's what we need for this problem. Now, in order to graph this equation, I want 2 points, and I'm going to choose as those 2 points the x-intercept and the y-intercept, because those 2 points are pretty easy to find. Remember, for the x-intercept, y equals 0, because this is the point where the line crosses the x-axis, and on the x-axis the y-coordinate is always 0. So we can substitute y equals 0 into our equation. Y equals 500x minus 10,000. Now to solve for x, we add 10,000 to both sides of the equal sign, and that gives us 10,000 equals 500x. Let me divide by 500, and we get x equals 20. So our y-intercept here, I'm going to scroll down a little bit, our y-intercept has the coordinates 20, 0. When y is 0, x is 20. For the y-intercept, we're going to do something similar, except remember at the y-intercept on the y-axis, x equals 0. So we're going to use that to find the y value of the y-intercept. Y equals 500 times 0 minus 10,000. 500 times 0 is 0. 0 minus 10,000 is negative 10,000. That's nice. That's also, if we notice, that's also where the submersible started in the problem. That was its initial value. So our y-intercept has the coordinates 0, negative 10,000. Now, in order to graph these points and get the graph of our function, I'm going to scroll down a little more because I'm going to need a little bit more room. I'm going to need a coordinate plane. Now, the reason I chose the grid layout for this video is because I want to have a very precise graph. I want to make sure I can graph all of my points very accurately, because that helps us see other things that show up on the graph. Now, notice my minutes are along the x-axis. We're counting by 2s. So we have 2, 4, 6, 8, 10, 12, and so on. On the y-axis, my elevation, I'm counting by thousands. 1,000, 2,000, 3,000, 4,000. I didn't mark all of the values on the graph because I need to make sure that I have room, and I need to make sure that this bottom one says 10,000 and not negative 1,000. Now, notice what quadrant I used. I used the 4th quadrant of the coordinate plane because my y-intercept is going to be on the negative part of the y-axis, and my x-intercept is going to be on the positive part of the x-axis. So this is really the area of the graph that I need here. Now I'm going to plot these points. I have 20, 0. So that is going to go on the x-axis at 20. Put a nice big point there. And 0, negative 10,000. That is our y-intercept. So we have those 2 points, and now we want to graph a nice straight line. Now, using a straight edge like a ruler or your student ID is always a good idea when you're trying to get a nice straight line. I'm going to cheat a little bit, and I'm going to use the software I have to draw a nice straight line here. Now that we've graphed a line, we can tell a lot more from this graph, a lot more information than is given to us in the problem. For instance, we know we have our starting point, right? At 0 minutes, the elevation is negative 10,000 feet. That's a point we know. We also know that at 20 minutes, the elevation is 0. Those are points we already found. But using our graph, we can see a lot of other points. For instance, at 4 minutes, see how that line crosses exactly through that intersection of the grid area there? We know that at 4 minutes, the elevation is negative 8,000, just from looking at the graph. We can also tell that at 8 minutes, if I look at 8 minutes, we have a nice little perfect point there that's exactly on negative 6,000 for elevation. At 8 minutes, the elevation is negative 6,000. At 12 minutes, the elevation is negative 4,000. And if you notice, we have a little bit of a pattern here. Every time the input, or the number of minutes, increases by 4, the elevation increases by 2,000. So 16 is going to be negative 2,000. We can tell that from the pattern, and we can also tell that from looking on the graph. So finding the intercepts is a good way to draw your graph, but once you've drawn the graph, we can gain a lot more information about all of the other points. This example is all we're doing tonight. You can go ahead and finish up your notes and submit them, and I will see you guys on Monday.